the landmass in the Northern Hemisphere allows. And so in the end, 38 sites over the Northern Hemisphere were examined for the 150-year period, 1846 to 1995. The results suggest that a warming was going on, so that the ice on date was about 8.7 days later on average in those 38 sites. And the ice off date in the spring was about 9.8 days earlier in the spring. So that's about 18 days total. And that represents about 20% of the average ice duration season here on Lake Mendota. And this is the long time series of Lake Mendota. It goes all the way back to the mid-1850s. We've been measuring the length of the ice season. And there's a contest every year. I don't know if it's been announced yet. Probably should be. It's going to be cold on Friday, but it's not going to be that cold for that long. But nonetheless, you can see a lot of interannual variability in the ice duration, but the long-term, the 5-year average is in red. The long-term trend, even aside from the 5-year running mean, is down. And we've lost a lot of ice duration. Remember that in 1998? I brought my kids down to the lake on February 28, 1998. We threw rocks into Lake Mendota. There was no ice on it. I told them that'll never happen again. I think I'm already wrong. And that was only 20 years ago. So that was amazing. But that was a big El Nino year. So, as I told you, I grew up in New England. I was a morning paper boy, too, when I was a kid. So I was out in the snow all the time. And especially, we got a lot of big winter storms when I was in those perfect years from about 10 to about 15. So it really caught my attention. I had a lot of things I was interested in, but that was one. And so when I moved to Wisconsin, I suddenly realized we don't get giant snowstorms. We don't get 12-inch snowstorms here very often. When we do, I celebrate. They happen occasionally. But I've transitioned. I don't mind the every third day dusting. You know, Jordan and I used to talk about this, how common that is, that most of the seasonal snow is delivered by minuscule little events, but an almost unceasing, train of them. So anyway, one particular winter in the recent past was exceptionally boring, and it got my goat. I can't stand that. It wasn't cold. It wasn't snowing, and I just could not stand it. I thought to myself, all right, John, you got to break your parochial view. It may drive you crazy. And I said, how am I going to break my parochial view? How will I be able to create for myself a measure of the winter intensity that will get me excited, even if things aren't exciting locally? So I thought, how about I'll look at how much area the -5 degree air, covers over the hemisphere at 850 millibars. And so that seems like a totally wild, random decision to make for that variable. But it's not that random. Since I'm interested in snowstorms, -5 at 850 is a guarantee for snow. If you've got a precipitation event and it's at least -5 over you at 850, you know it's going to snow. You might be able to get away with it even at -1, but -5 is a guarantee. So I had that in my head as a synoptically important boundary. So that's what made me think, let me just take a look at this -5 aerial extent at 850, see what it's all about. So here's a day, 2nd of February, 2012, where it's not that cold over Madison, but it's cold in a lot of other places. As you can see, we were warmer than -5, another boring day from that winter. But the blue area has an area that the blue shading has an area that you can calculate every day. And if you take a look at the NCEP reanalysis data, you have a data set 4 times a day from 1948, January 1, all the way to the present time. That's a big, nice data set to look at. Now it's getting on 70 years. And when you start to play around with that data set, you can do some interesting things. If you're a winter freak like I am, what was the coldest December, January, February moment of the last 60 or 70 years? And that was the 21st of January, 1984, when the -5 isotherm looked like that. So that has the largest aerial extent in the last now 70 years. And what was the warmest December, January, February moment in the last 70 years? That's December 2nd, 2003. The difference, when you look at it on such a graph as this, it doesn't look that big, but it is big. There's a big difference between those two in terms of aerial extent. Okay. You can also look at the long-term average. To this point, this was through 2013. This is the daily average, and I put January 15th in the middle of the diagram. The daily average aerial extent of air with a certain temperature at 5 different thresholds at 850 millibars from the NCEP reanalysis data. Beautiful sinusoids. Of course they're going to be sinusoids. This is a long enough time series that only the cosmological forces are at play in this long-term average, right? The tilt of the Earth away from the sun in the northern hemisphere in the wintertime and the progression of the sun through the year. So it's a really nice picture. What's more interesting is 4 times a day, times December 1st through February 28th, no leap days, 90 days, 360 such aerial calculations per cold season, and then average them all each year. the top line is the -5 degree isotherm or aerial extent of -5. Then I've got 4 more temperature thresholds, -10 all the way to -25. So each dot represents an average for each cold season of 360 calculations. And I looked at 3 different data sets. They don't even overlap in time, but they have some commonality. NCEP reanalysis, the ERA 40, and the climate forecast system reanalysis, which is another NCEP product. And that's in green. And you notice that from year to year, there's variability in how much average aerial extent of cold air there was. But the long-term trend, this significant at the 99.9% level, is downward. And that's the black line in the middle. Really interesting. And that's true at every threshold temperature. In fact, at -20, it has almost the same aerial extent as the Arctic sea ice in late February, which is sort of the peak extent. And it's going down at the same rate. So that's really neat. So there's a systematic decrease in the amount of area that a cold season actually has at -5 degrees at 850. And the only way that can be explained is by radiation changes. Because you can't do it by advection. All you're doing then is changing the morphology of the -5 isotherm. You create cold air by losing energy to space. And when that starts to happen December 1st to February 28th, that radiation condition doesn't change unless something about the chemical composition has changed it over that period of time. So that makes a really interesting thing to study. And here's another way to look at it. These are now normalized seasonal average area. Where it's blue, you have greater than the long-term average extent by a certain number of standard deviations. Where it's red, you have a smaller than the long-term average. And then superimposed on that is the Hadley Center, I think it's the Hadley Center, reconstruction of temperature, average surface temperature for those months over the same period of time. And the correlation is like 0.834 or something high like that. So what happens at 850 is representative of what's happening at the surface. The nice thing about 850 is you don't have to worry about where your airport is or where your thermometer was. So that's kind of nice. You get rid of a lot of that contamination that sometimes is a little bit of ammunition for skeptics. They might catch you a little flat-footed. Did you move the temperature measurement from downtown to this place out in the country or vice versa? Well, yeah, yeah. But you don't have to worry about that at 850. So that's nice. And then the neat thing is you can look at the daily time series in certain years against the long-term average. So the blue line is the long-term average from December 1st to February 28th, and then it's straddled by plus and minus 1 standard deviation. Again, calculated over the whole long time series. The green line here is the season 2011 and 2012, which instigated this whole thing. And so you can see in the first half of the season, the whole hemisphere was about average. And then suddenly mid-January to the end of it, everywhere else was cold except us. That's what got me frustrated. And you can see that reflected here. And then 2013-14, how many people remember that winter here locally? It was pretty cold, wasn't it? Look at that time series over the hemisphere. At the time, it was the warmest hemispheric winter since at least 1948. And then the next year was the warmest after that by this measure. Imagine that. So we were freezing here in the winter and we were way below normal for hemispheric extent of such cold air. So it occurred to me, if I go back this way, yeah. It occurred to me, you could have fun doing this. Saying, look, there are certain days where you're at least 2 standard deviations below the average in terms of aerial extent. There are also days where you might be 2 standard deviations above. So I just picked this out of thin air as the criteria. If I'm 2 standard deviations above the daily average for that calendar day, that's going to be an extreme cold day. If I'm 2 or more standard deviations below the daily average for that day, I'll call it an extreme warm day. So look at how those things line up. On the left are the 2 sigma or extreme cold days, and they're all front filled in the time series in the 40s through about 1990s. And then the warm events are some of them are scattered in the first half, but they're mostly concentrated in the second half by this measure. Okay. And I'll fill it out for you. I know you can't read all that. There were 117 individual days that met the criteria over the 70-year time series that met the criteria for an extreme cold day for the hemisphere. So they're listed there by calendar date. Not a single one since 1994. Not one. That's unbelievable. And then 187 warm days in the whole time series, 104 of them since the year 2000. Now that speaks to loaded dice. And it's very hard for anybody to not get on board on that. Something's going on here for these extreme events. Here's a little glimpse into what we might be seeing this winter, but I don't know that yet. I'm interested to know what happens if the months leading to winter are cold around the hemisphere. How often does that lead to a cold winter or vice versa? So the blue line is the September 1st to December 31st long-term average. So that's 69 years or 60, whatever, 67-year average. And for the aerial extent of -5, starting on September 1st. And then the red line is the daily time series up through Halloween, okay, including Halloween. And we're below average for the hemisphere for cold air production up to this point in the season. And I just point this out too, that I'm cheating a little bit by using a long-term 60-plus year average. But if I use the more standard climatology, the 30 years that we won't roll over until 2020, there's hardly any difference between the 1981-2010 average and the longer-term average. It is a little bit warmer, but even so, our daily time series up through Halloween is well below normal. In fact, the month of September here was 2.7 degrees above normal in Madison, and October was 1.1 below. So we had a mix in September and October. Hemispherically, September was the 21st warmest, so really run-of-the-mill, not that impressive, out of 71 years. October was the 11th warmest out of 71. Oh, 6th warmest, sorry. And the combination of September and October was the 11th warmest September and October out of the 71 years by this measure. So the hemisphere is warm, even though we just had a cold October. Again, almost like 2013-14. So I find that really interesting, and I want to explore that a little bit more. I have no idea what the early part of the cool season means for the late part of the cool season yet, but there's a lot of statistics to plow through to have some fun with that. So anyway, that's been really interesting to me. So I have some conclusions that over the last 67 years, the Northern Hemisphere, December, January, February average extent of cold air at 850, the -5 cold air, has decreased by 4.5%. And a lot of times in an audience that's not trained, as many of you are, almost all of you are, people will say 4.5%, and that's nothing. Then I'll tell them, well, you know, if you take the standard sea level pressure of 1,012 and drop it by 4.5%, you're in the middle of a Category 3 hurricane. So in the atmosphere, 4.5% means a lot. It means an awful lot. This is a finely tuned machine we're talking about, and we're talking about the whole hemisphere, not just one region. And that's gone down 4.5%. And there's no real good way to explain why each successive year, or at least in the long-term average, there should be an encroachment, an erosion of the extent of that cold air, except by radiation that's been retained in an anomalous fashion over that same time series. That's the only way to really explain it. So it's a result of greenhouse warming. And this is really great. Extreme cold events have ceased in the Northern Hemisphere. I plucked this definition out of midair, but still, it's amazing that this is true, that these events have ceased while extreme warm events have flourished. If the score is 141-0 since the week that I interviewed for this job. Okay. In fact, Aubrey, you made me think about it. My son was born in 1995. He has never experienced in his life an extreme cold day in the Northern Hemisphere winter. Not once. And it's likely he never will, by this definition. That's wild. That is really wild. But scientists are a skeptical bunch, and that's a good thing. I'm not complaining. I'm 0 for my last 6 in NSF proposals. Right? This is my worst drought of all time. And it reminds me, I got to feel like Ted Williams in the on-deck circle with 3 bats in my hand. He's 0 for 8, maybe. It's about as bad as it got. He'd say, I'm Ted effing Williams. I'm the best hitter who's ever lived. That's how you get out of a slump. I'm keeping my language a little bit more non-salty, but I'm thinking the same thing. I have to get my act together and get this going. But I'm glad for that skepticism. In the second IPCC report, this was a statement they made. I'm sorry, that thing's in the way. The balance of evidence suggests that there is a discernible human influence on global climate. Wow, that's kind of a vanilla statement, isn't it? That's 1995. And so we were not rushing to make a statement that, there was some hoax being perpetrated by people around the globe. This is extraordinarily conservative, and it's only 23 years ago. And then, knowing that things may change, the IPCC decided that they should do, after looking at more observations and more analysis, they better have the worst assignment of all time for certain scientists in the community. How many of you have had to do committee work in your professional careers? Everybody, right? George Will, the great political writer, says, football embodies the worst 2 characteristics of American life: violence and committee meetings. And we can all agree on the second part. Committee meetings are terrible. Imagine being on the adverb committee for the IPCC. What are these words going to mean? Things like likely. It's at least a 66% probability statement. What is very likely going to mean? What is extremely likely going to mean? To their credit, they decided what these words meant before having to use them. This was a genius stroke, but it must have been exceptionally unpleasant work. 0% probability of enjoyment, right? But it was good they did it. In the third assessment in 2001, most of the observed warming over the last 15 years is likely to have been due to the increase in greenhouse gas concentrations. That's about a 66% probability statement on the bottom end anyway, of what that word means. More refined observations and analysis. And as Ankur said, more things included in some of the modeling. So more sophisticated modeling and incorporation of other processes, ecological processes and other physical processes. Most of the increase in globally average temperatures since the mid-20th century is very likely, that's a 90% probability statement, due to observed increase in anthropogenic greenhouse gases. And then again, more refined observations and analysis. And in 2013, with the fifth assessment, it is extremely likely that human influence has been the dominant cause of the observed warming in the last half of the 20th century. That's a 95% probability statement. And the new report is due this year. And I think we got the first couple of weeks ago, didn't we get the first kind of statements coming from the committee? Yeah, we better watch out. We got about 12 years to go or something before things really get out of hand. So I'm sure we're going to go above the extremely likely category in a similar statement in the next report. So again, as a means of conveying to you the way that I've attacked the problem of communicating with, the public with whom I make interactions, I try and suggest to them, this is not the series of statements over 20 years of an agenda-driven group of people. The only agenda is to try and understand how nature works. And with each successive report, and it takes many years between them, every one of them is about 6 years separate, there's an enormous amount of additional work that goes in there. Any of us who are publishing in the literature know that if your last result is 6 years old in whatever you do, no one knows your name anymore. So people are constantly pushing the envelope forward and learning new things and incorporating those new things into their projections. So this is not an agenda-driven thing. This is a function of a deep, strong desire to understand nature. And what we, I think, can say now is that there should be no controversy at all about whether or not the planet is warming. And at a modest or maybe unfortunately rapid rate, there's a number of different pieces of evidence that point that way. What we need to do is think about how will we work to solve the problem, because the debate about whether there is a problem or not should long be over. And I think if we can put our energies towards the solution, we'll be a lot better off. So I'm really interested to hear in the conversation part this afternoon, what sort of challenges have you all faced, operational meteorologists and broadcasters, in terms of communicating this message? I have a feeling there'll be some overlap with what we've found ourselves, but there'll be also some places where we can learn about what some of your strategies have been and inform our own subsequent efforts. So I'm looking forward to that. So I'm happy to take any questions, and thanks for your attention. Yeah.
Martin, if you look in your research, is there a change at all in the date of the peak of the season coverage of the -5?
Oh,
does it shift at all? Is there any change there?
That's a really interesting question. I don't think I can say that I have done that. The peak of the year on the long-term 66-year average is February 5th. Oh, no, January 29th at -5. So that's about the coldest day of the year hemispherically by this measure. I don't know whether it's shifted from the 1950s and 60s to 2000s and 2010s. That's a really good question. I do know that the date at which, going back to September 1, if you start counting September 1, the date by which 1 billion square kilometers have been accrued, so you just add up every day's aerial extent, that has become 10 or 12 days earlier now. Later, sorry. It's 10 days later than it used to be. So it's taking longer for the hemisphere to cool down. And so that is a discernible pattern. But it's really interesting to know about the shift. I don't know the answer to that off the top of my head. Haven't done that one.
Are you seeing any change from 2 sigma warm events in the calendar?
No, actually none. So that's a good question too. None. In fact, it's not even a regular occurrence that each year has the same number or an increasing number. So that is somewhat random. The interesting thing that's not random is you never get cold ones anymore. So there's something, there's a population that's boiling up and down every once in a while in a winter where you can get a really extreme warm day, but you never get conditions that lead to an extreme cold day. That's an interesting point. But there's no shifting as far as I can see in the number or in the calendric location of those extreme warm days. Yeah, Jordan.
So yeah, like you, after the 2011, 2012 winter, I started getting kind of interested in this as well. what is it, you put any thought into what is it about North America that tends to buck the trend of the rest of the hemisphere or the world in these events? Because it seems like it happens more and more often that Eastern North America in particular is opposite of what we're seeing in Siberia, Europe, other places.
It's really interesting, and it's just
Paraphrase that a little bit.
Oh, yeah, sorry. It seems that, at least anecdotally, in a couple of the examples that I presented, and true throughout the time series, that North America bucks the trend of the rest of the hemisphere. So, in other words, if the hemisphere is warmer than average, we're colder than average, and vice versa. It's true even this fall, because until early to mid-October, there was an incredible temperature anomaly over Mongolia and Siberia, very warm, well warm above average, 3 standard deviations or something. It took forever for cold air to get in place at 850 in that location. Meanwhile, we're sliding from our warm September into a fairly cold October. I don't know what's going on there. And Dan Beaumont generously had volunteered some years ago, and I never took him up on it, maybe I will now, to look at it, because I can do regional aerial extents as well, and just see how those regional aerial extents over North America compare to the hemisphere, or maybe the rest of the hemisphere would be the best way to do it. And just see, is there anything systematic about this, otherwise anecdotal sense that they seem to seesaw back and forth with opposites? I don't know the answer to that, but it's intriguing. It's really intriguing. There's been more than a few examples of that, and it's worth investigating.
Do you think that would be a next sort of?
Yeah, it's a good place to go, because I mean, in the end, aside from the radiation condition that underlies the whole thing, the variability around the hemisphere has got to be tied to circulation anomalies. And to some extent, they must be systematic to be doing this kind of thing. And so one wonders where they come from and why they behave the way they do. It's a really good next question. Yeah. And then, of course, there are sensible weather consequences beyond the cold air that come from these circulation anomalies. That'd be interesting to know those. So.
Thank you, John.
Yeah, thank you.
Thanks.
All right, well, while Ankur's getting this loaded up, I realize I am keeping you from your break. I am the talk that keeps you from your break. So I'll try and blitz through some of the stuff that I have here. So quick introduction, my name is Dan Beaumont. I'm a professor here. I've been here since 2003, which I think makes this my 15th year.
Yeah.
Which is exciting. I got 3 kids. I love fly fishing. Anyone else fish or fly fish? All right, we should go out fly fishing. I don't know why we haven't yet. I'm a big Gonzaga basketball fan. Any Gonzaga basketball fans? There we go. All right. There's another one. And I grew up 5 houses away from the Seahawks training camp. So I'm a big Seahawks fan until the Fail Mary. And then when the Seahawks play the Packers, I find myself cheering for the Packers. It's amazing. So my research focuses on climate change impacts in Wisconsin, at least the research I want to talk about here. My background is I study things like El Nino and the Southern Oscillation. So I really enjoy looking at how 2 fluids on a rotating sphere interact with each other. And I can bore you all to tears with a talk on that, or I can talk about climate change in Wisconsin, which I'm going to talk about a little bit here today. And I'm going to tell some stories today. And there's a reason why I'm specifically telling stories. The way we communicate with the public as scientists, the way we communicate with other scientists is very different than the way that I tend to try and communicate with the public. And this is something that is, well known outside of scientific communities. But as scientists, we still have this idea that if we just, show them how the math can derive the result that we think, then people are going to actually believe what we have to say, and it's just not true. People relate to stories far more than the science. The other thing I'm going to try and emphasize here is that it's through telling of stories and it's through us as scientists listening to stories that we can start addressing things like climate change adaptation. So I want to talk about that a little bit here. If you've seen me give a talk before, I apologize. I've only got 1 set of jokes. I'm not creative enough to come up with a second one, so you're going to hear them again. I had a rowing coach that said, if you see a turtle on a fence post, chances are they didn't get there by themselves. That's my Thanks, I'm the turtle. Lots of other people contribute to this. So I start off, I give a lot of talks around the state, and I usually start off with 3 things we know about climate change. These have already been introduced, which is great. I want to tell a story about one of them at least. This is Christina Slani on the bottom left here. She runs the drilling, the design and operations for the Antarctic and Arctic drilling operations for the U.S., which is run right out of here at Space Science and Engineering. And this is, I think, the last bit of the core of one of the cores at Vostok. I could be wrong on that, but that's in Antarctica. This is 800,000 years of carbon dioxide based on those bubbles that are trapped in that core of ice. And it never ceases to amaze me that we have 800,000 years of data of actual observations of what happened back then. As snow accumulates, that snow has air in it. More snow accumulates on top. It packs that snow down, becomes ice, and then air gets trapped. And we can then pull the ice up, melt the ice, get a sense for what actual air was there. Just never ceases to amaze me. So from the history of humans, not the history of human civilization, that only goes back 6,000 years. That's like right here. The history of humans, like emerging from the African continent, carbon dioxide has varied between about 150 and 300 parts per million. Okay, this is what's happened lately. We passed 300 parts per million sometime early in the 20th century. The story I like to tell here is that, is of this record, which is the Mauna Loa carbon dioxide record. And this is Charles David Keeling, who was responsible for taking these measurements. He took these measurements for 3 years and ended up with a really cool result. He found that the Earth breathes, right? That during the summer and spring, when in the northern hemisphere, when things are greening up, that greening draws carbon dioxide out of the atmosphere for photosynthesis. So carbon dioxide in the atmosphere goes down. And then when those plant leaves fall and decay, they release carbon dioxide back to the atmosphere, and carbon dioxide goes back up again during fall and winter. So he found this breathing of the biosphere, which is this really cool result. And he could have stopped after 3 years, and it would have been great. It would have been an outstanding result. But by his own perseverance, he continued to take those measurements. And now we have the single most iconic piece of information that we have related to climate change, the long-term increase in carbon dioxide at Mauna Loa. And I don't have in April 2011, I believe, let's see if I got that right. Nope, 2014. For the first time in the history of humans, not of human civilization, of humans, carbon dioxide concentration passed 400 parts per million. That sounds really remarkable, but it's not nearly as remarkable as what happened next, and that's what I think is even more amazing. Carbon dioxide fluctuated just like it does, the annual cycle, came back down below 400, up above, down below, and then in November 2015, carbon dioxide concentrations crossed 400 parts per million for the last time. No one living on the planet will ever again experience carbon dioxide concentrations below 400 parts per million. When we reach 500 parts per million, not if, when we reach 500 parts per million, we will say the same thing. It's very likely that we will say the same thing at 500 parts per million. That's a reality that we're living with, okay? And that can be a depressing reality, or that's the most predictable damn time series you're ever going to see in this field, right? And so that gives us information. We can start thinking already about the potential implications of this. And I'm going to get to that in just a second. We've already seen this, carbon dioxide. And actually, as we were looking at this, I realized I have only experienced in my life 2 years below normal. With below normal temperatures. That tells you how old I am. I'm going to quickly switch that before you realize just how old I am. And then we also saw this, that the third thing we know about climate change. So the second thing we know is that our climate's warming. Happy to talk about evidence, different ways we estimate that. Adjustments to intake temperatures on ships versus bucket temperatures, these sorts of things. And then the last thing, we know that it's due to carbon dioxide. If we try and reproduce the warming over the last 100 years, we can only reproduce the warming over the last 50 years if we include greenhouse gases and other anthropogenic sources of forcing. All right, so those are three things we know about climate change. What's next? So these are 4 different scenarios. We don't know how the global economy will evolve over the next 100 years, and so we come up with these scenarios of how our economy may evolve and how carbon dioxide will continue to increase in our atmosphere. So this is potential temperature warming. This is the temperature warming that could occur based on these different storylines. And so this blue curve, RCP, radiative concentration pathway 2.6, is one where there's a rapid movement away from a fossil fuel-based economy. Population peaks early in the century. Not a whole lot of accumulation of carbon dioxide. And this, we end up with about a degree, maybe a little more, of climate change as a result of that. I don't think anyone thinks that's a realistic scenario, unless you're in Europe. In Europe, they still, you go to these conferences and US scientists are like, yeah, this is fairy tale land. I mean, this is not going to happen. We're already well above all of these, by the way. This blue curve of 4.5 is about 2 degrees of warming, and this red curve is about 4 degrees of warming. And that's, the red curve is a business as usual, population peaks late, nobody gets along, we don't share technology, however our Earth kind of evolves in the next 100 years. This sounds really depressing, I'm sorry. I give this lecture to my 101 class, and at the end of the class, everyone's just kind of sitting there staring at me. Like, just remember, you will fall in love, you will see beautiful places in your life, you will be amazed at things, it's just all gonna happen while things are getting warmer. So, what scares me about this scenario is that it hasn't even begun to level off, right? Look at the derivative here, it's still continuing to warm. And that gets up to about 12 degrees Celsius of global warming if you let that go out for another 300 or 400 years. That's a completely different planet. That's uninhabitable areas on our planet. Meaning uninhabitable, not just because resources aren't there, because humans can't cool off. Uninhabitable. What can we do? The two options, well, there's a third option here, which I'm not going to talk about much, but generally we talk about mitigation and adaptation. Mitigation is some sort of activity that we can take to take us from one of these scenarios down to one of these other scenarios. So reducing carbon dioxide emissions, drawing carbon dioxide out of the atmosphere, which could be geoengineering, be a third one you could put in here, but kind of falls under mitigation. But even if we are able to mitigate, even if we go from, currently we're above all of these scenarios, so even if we go from an RCP 8.5 down to a 4.5, there's an inevitable amount of climate change that's already, that we know is going to happen. And so we need to be prepared to adapt as well. So this isn't an either or venture. This is both of these things need to be happening. And our work with Wisconsin Initiative on Climate Change is focused on adaptation. There's a third thing that I think is inevitable, and that's geoengineering. I don't see any route in our next 100 years that does not involve geoengineering. It's just too easy to do, and it's a wild west out there. We have no idea what's going to happen, first how it's going to happen, and the potential impacts of geoengineering. Our law structures are not set up to deal with these sorts of things. You can imagine that as soon as somebody decides to launch a bunch of aerosols into the stratosphere and cool the planet, the first hurricane that hits anywhere, someone's going to sue that person, right? Because how do you know it wasn't due to those aerosols? So there's a lot of really interesting questions that we're currently facing as a society and as a community around geoengineering.
It happened in 1950 with cloud seeding.
Yeah.
North Dakota, South Dakota started suing each other for precipitation, right?
There you go. Yeah. It's a wild west. All right. So all that's great. And I want to tell another story about what does it actually mean? So I had a guy come into my office about 2005 or so, and he built augers to drill for ice fishermen to drill into lakes. And excuse me, he only builds big augers, right? Their company for thick lake ice. And he comes in and he says, look, I got to know that the last few years are going to be the norm for the future, because if they are, then our business has to change business model. And at the time, my response to him was, well, global temperature is likely to increase by 2 to 4 degrees Celsius over the next 100 years, which is useless to this guy, right? He wants to know, what does it actually mean for my business? And so that's what we've done with the Wisconsin Initiative on Climate Change Impacts. The Wisconsin Initiative on Climate Change Impacts is it's a network of individuals who communicate back and forth to identify what are the problems, what do people care about, and hence, what information do we need to be providing? What can we provide, and hence, what can people actually plan for? It's a two-way conversation that needs to occur, where it's not just us telling information, it's also us listening to information, which is really the Wisconsin idea. Wiki.wisc.edu, if you want to, our website will be updated in the next few months. It's pretty terrible right now, so just warning. So as part of Wiki, we put together a bunch of projections for warming in Wisconsin, and we also took a look at historical warming in Wisconsin. So this is a historical change in annual temperature in Wisconsin. Wisconsin's warmed by 2 to 3 degrees Fahrenheit since 1950. Everywhere you see an asterisk, which you don't see any here, if you see an asterisk, it means that the trend is not significant. And so that trend is statistically significant over all of Wisconsin for that warming. Moving forward, this is the most boring map on the face of the earth, which is a big orange dot. It looks like Wisconsin. How much will Wisconsin warm by mid-century? This is 2050 conditions. By 2050, it doesn't really matter what scenario we're on. They all kind of look the same. By 2100, there's a huge difference between the different scenarios. By 2050, pretty much everything looks similar. And so Wisconsin, this just looks like Wisconsin will warm by about 5 degrees Fahrenheit, or 5 or 6 degrees Fahrenheit, which kind of tells me nothing. So what we like to do instead is express this as a probability distribution. And so I'm more comfortable saying Wisconsin is expected to warm by 3 to 9 degrees Fahrenheit by mid-21st century. What does that actually mean here? Those are quantified numbers here. This is the 10th and the 90th percentile. So to put things in perspective, there's a 90% chance that Wisconsin will warm by more than 3 degrees Fahrenheit by mid-century. There's also a 90% chance that the warming will not exceed 9 degrees Fahrenheit by mid-century. Now we can start making decisions. If you have a system that's susceptible to a 4-degree temperature change, there's a 75% chance we're going to exceed 4 degrees Fahrenheit warming by mid-century. So you better start making plans for how you're going to adapt to that. On the other hand, if you have a system that's susceptible to a 12-degree Fahrenheit temperature change, it's only like a 2% chance we're going to exceed that by mid-century. And so you don't need to do anything in terms of adaptation. And that's the right answer for a lot of people, is to just continue doing what you're doing and make small adjustments and keep track of how things may be changing. On the other hand, if you go over a waterfall with a 12-degree Fahrenheit warming, then you put in place contingency plans and so forth. So once you enter this sort of risk assessment framework, you can start thinking about these climate impacts in a decision relevant sense. This still, though, it's hard for me to say what does this actually mean, right? Winter warms most in Wisconsin. In the historical record, we've seen more warming in winter than the other months, and the projections show the same thing using climate models, independent data. So both the projections and the historical warming are consistent in this case. Winters will warm by 5 to 12 degrees Fahrenheit in Wisconsin by mid-century. What does that mean? This is a picture of Governor Nelson. Governor Nelson? Yeah, on the ice ridging near Governor Nelson. And we already saw this plot. So another story to tell. I'm showing this plot. You don't need a trend line on this to show the decrease in the duration of ice cover. So this is the duration of ice cover on Lake Mendota in days from 1860 to present day. And this is the way you determine this. You go out to Picnic Point, and if from Picnic Point to Maple Bluff is covered in ice, even if it's like a thin walkway of ice, then Lake Mendota is ice covered. That's the official definition. The nice thing about that is that there's not a whole lot of variation in that definition. And so it's a consistent time series. We don't need to worry about things like air stations moving and so forth. The thing I love about this, 1880 to 1881, 162 days of ice cover on Lake Mendota, which is just awesome. Yeah, so a good story. What else happened in 1880, 1881?
Big blizzard in March in the Dakotas was there.
Big blizzard in March in the Dakotas. What about, let's expand on that. Literature, things you probably read when you were Was there a volcano then?
Lots of.
There may have been. Yeah,
Laura Ingalls Wilder, The Long Winter.
The Long Winter. The most historical of all of her writing was about the 1880 to 1881 winter. I mean, this is when there was 10 feet of snow drifting in parts in Minnesota. I just looked at the 20th century reanalysis, and October 10th, there's this. I mean, the 3 days leading to October 10th, there's these giant cyclones sitting right over, right just west of Minnesota. Equally depressing, these years with very little ice cover. This has a big impact on ice fishing, obviously. It also has a big impact on piping plover populations. Piping plovers are a bird that pretend that their wing is broken to try and lure predators away from their nest. And so when there's more ice scrubs away vegetation from their shoreline nesting locations. And so there's less places for predators to hide. And so more ice is good for piping plovers. I studied two fluids on a rotating sphere. I wouldn't know a piping plover if one, hit me in the head flying by, right? The only way I know this is by talking to people who study birds, ornithologists, people who in forest and wildlife ecology, who know more about piping plovers than I do. And so it's through that communication that I'm able to learn from them and say, oh, now I see what information is necessary to start thinking about adaptation strategies for restoration and so forth. Another example, anybody ski the Birkebeiner ever? Nice. Wayne's got his hand up on every one of these so far, except for take a basketball, so I'm gonna work on him. Yeah, I'm gonna work on him on this one. Birkebeiner, Ned Zielsdorf, the director of the Birkebeiner, was part of the Wisconsin Initiative on Climate Change Impacts, and we came up with projections of looking at the characteristics of snowfall in wintertime. And so this blue curve is the probability that something falling from the sky will be frozen, all right? And so in middle of February here in Madison, and we've done this for up north as well, in Madison there's about 9 out of 10 precipitation events will be snow, 1 out of 10 will be rain, okay? And so you can kind of use these 50-50 days, and actually I got this from John Martin, these 50-50 days as the bounds on your winter season example. So this is what day, John?
November 15th.
There you go. Yeah, it's been pushed a little towards November 18th. I always think November 18th is the 50-50 day. And those days contract quite a bit. So we see a shortening of the snow season, shortening of the characteristics of the winter season, and hence shortening of winter recreation and so forth by about 3 weeks on either end. So that's a big change by 2050. So we can start making decisions about what this actually means to people. Talking to Ned Zielsdorf, I said, look, we can start looking at probability, the amount of snowfall on the ground in late February, the time of the Birkebeiner. And he said, we don't care about snow on the ground in mid to late February. And I thought that was ridiculous because that's when the race is. And he says, no, what we care about is that most of our skiers come from Minneapolis and Chicago. If they train for the race, they sign up for the race. If they don't train for the race, they don't sign up and we have a bad year. So what we care about is the characteristics of the snow season, the entire snow season ahead of time in Minnesota and Chicago. So again, as a climate scientist, I'm coming into this with this preconceived idea of what's important, but it's only through conversation and listening to stories that I'm able to say, oh, wait a minute, this is what the research is really important here. I'm gonna skip for a few, skip forward, talk about freezing rain quickly. This is just something I put together quickly. Currently, the band of climatological freezing rain, most freezing rain sits over here in for the historical period, sits here in mid Illinois. Does that ring a bell? Does that seem like it's about correct?
Yeah.
Okay. This is the analog. This is an analog map, and it says, what's the closest analog to Madison, Wisconsin, for Wisconsin's future climate here? And the closest analog by mid-century is this sort of area around here. So potential increases in freezing rain, if that's the case. I would expect then this freezing rain to kind of shift north. That's something we're looking at right now. We're trying to hire either an undergraduate or a short-term graduate. If anyone does stuff on Bayesian analysis or Bayesian classification of freezing rain, I'd love to talk to you because I don't know much about the subject.
Is that an open source tool that anyone can go to
Yeah.
and play around?
Yep, it's on the wiki website as well. I'm going to skip forward to summer temperature in Wisconsin. We've seen no significant upward trends in summer temperature in Wisconsin over the historical record. That's really interesting. We're one of the few places that have not experienced those trends. The projections show that we should warm by 2 to 8 degrees Fahrenheit, which is the least amount of warming of any season, which is also consistent with observations of the historical trends. And as we saw, that matters a lot for brook trout that start dying off. Once stream temperatures get above 19 degrees Celsius, brook trout start dying. Anybody want to venture a guess as to why? Stream temperatures get above 19 degrees Celsius and brook trout mortality rates increase considerably. Yeah, so that was perfect. Who said metabolism? There you go. I said oxygen, and that's what I would say, and I assumed that was the case. Wrong. It turns out there's enough oxygen in the water for that. What happens is, and this is the limit of my understanding of the word metabolism, but the little enzymes they use to convert carbohydrates into energy start unraveling at that point, which means that physically they cannot produce energy to live. If it gets above like 22 or 25 degrees Celsius, they've got 2 minutes to live because they just can't produce energy. They can't metabolize energy. And they're just a gorgeous fish. They're the only native trout. And this is just in here because I got to put a picture of a trout in a talk. All right. Last thing I want to talk about quickly, because I'm keeping you from break, is what does it actually mean in terms of summer warming? One of the things we did in coming up with these projections for Wisconsin is we realized that all of the existing methods for downscaling climatic conditions failed in representing extremes. So we had submitted a proposal to produce this downscale information over Wisconsin. And as that was being reviewed, we had conversations with people all around the state about what kind of information they needed to use. The proposal got funded. We sat down on early September, 9 a.m. We sat down to start looking at how we'd start this downscaling. And by 9:10 a.m., we realized that the methodology we had proposed would not meet the needs of the people who wanted to use the data. So we scrapped the entire methodology and came up with a new methodology from scratch that allows us to represent extremes in a very realistic way. And so this shows changes in extremely hot days where the temperature gets above 90 degrees Fahrenheit, which only happens about 10 times a year here in Madison. By mid-century, that's 30 times per year where the temperature gets up above 90 degrees Fahrenheit. And that's just the median. It could be way higher than that.
What do you mean by downscale? You mean down to
So-
like a Coney level?
Yeah, I'll show you that. No, I'll show you down to the global climate models.
Yeah.
Spatial resolution is pretty coarse, and it's not very representative of what you would get in a gauge, for example. So we're downscaling to representative of a point. Obviously, we're not telling you what's exactly going to happen at a given point, but the statistics of what could occur here in Madison are really not that much different of what could occur in Middleton, for example. And so as long as you're maintaining stationary statistics on a large scale, you can start looking at changes on a small scale. So we're looking at the distribution of what could be occurring at a point given the large scale conditions on a given day. I'm happy to go into that in more detail. More important than daytime temperature is nighttime temperature for human health. If people can't get to sleep at night, they can't cool down, they don't sleep well. And if they don't sleep well, then it exacerbates a whole series of other health impacts. And so we see four times more hot nights in Madison where the temperature doesn't get below 70 degrees Fahrenheit than present. Also, in terms of duration of heat wave, 3-day heat waves where the temperature doesn't get below 90 degrees. That happens consecutive days where temperature doesn't get below 90 degrees. That happens about once every couple of years here in Milwaukee. That's likely to happen 3 times 30 times every 20 years, however that works. It's a 3-fold increase in that. That matters because when I first showed this to a bunch of people in the energy industry, I showed the 5-day heat wave, and they said, we don't care about the 5-day heat wave, we care about the 3-day heat wave, which, like, who cares? 3, 5, I'm just, trying to make a point. They said, no, in 3 days, we pay people not to turn on their air conditioner. And after 3 days, they get really sick of being hot, kind of like this room right now, and you listening to me talk in this room right now. And so after 3 days, they start turning on their air conditioner, and they forget about this, about saving energy, and that's when their danger of a brownout goes up. I'm gonna just skip the rest of this precipitation. The one that's obvious here is the increase in extreme event rainfall, which is consistent with the projections as well. I'm happy to show that. This was a model simulation that was done in 2014 for the isthmus, and this is what September 2018 looked like. There's the flood risk in this region here. We lucked out in Madison with that rain, because 75% of that rain fell on the drainage basin to the Wisconsin. If that had fallen in the Mendota drainage basin, there's almost no way the dam would have held, and we would have seen this.
Right. It's like Venice. We've been archipelago.
Yeah, and check this out. This is Camp Randall right here, right? Flooding to Camp Randall, right? And so when they showed this to the physical to the folks at UW libraries, they were like, "This is a disaster." I mean, Memorial Union Library is right over here, or wherever it is. And they said, "Well, it's only a couple of inches of water. It's not like you're 6 feet of water." They said, "No. All of our rare books are kept in the basement of the library, which would be completely flooded." So little things like this, stories like this, can get people to start thinking about their vulnerabilities. As an individual, even though we don't need to say this is due to climate change. We can say this is a potential thing that could have happened. Because by thinking about that, we can start making better decisions and adapting. I'm gonna leave with a bunch of resources. Wisconsin Initiative about climate change impacts. We work across a whole variety of sectors in our state and with people all around the state and the country, really. And then a variety of other resources for looking at climate change impacts and implications. So, thanks. Do you want to skip straight to break, or if anyone has a burning question, I'm happy to take them at break.
Yeah, we can take a couple questions. What do you
Sure,
think
I'll
here?
take a question too.
Yeah, and again, we'll have a chance for more questions at the end of the whole presentation, but go ahead.
Yeah.
So your whole premise has been, let's sell this idea as stories versus stats. And in your personal experience, does that kind of allow us to, I don't know, sometimes people want to feel like we have to be polarized about climate change, but does this allow you to kind of bypass that conversation and say, let's find a solution to whatever problem you're dealing with now on a hyper-local scale?
Very much so. I think, so the question is, does this allow you to kind of bypass the polarization? So I did two things in bypassing that polarization. Whenever I talk to people, I say, climate change involves two questions. What's happening and why? What are we going to do about it? The first is a science question. The second is a policy question. I'm going to focus on the first, and we're going to work together to come to the right questions to ask about what to do about it, so that we together are working on the second question. And so that's one initial way of just saying, look, I don't care about what yammering back and forth in the political arena is saying. We're going to come to this second thing together. So that's one. Actually, I listened to this podcast on an FBI hostage negotiator buying a used car, and his strategy for this was get the person on your side initially. So when you're calling like a helpline or something, or so I've done this with Delta Airlines where I've screwed up my tickets. I'll call up and I'll say, okay, what's your name? And this is Sandra, the supervisor. I'll say, Sandra, you and I need to work together on this, because we got to succeed in figuring out how we're going to get my ticket changed so that both of us can succeed. It is actually research that says getting people on your side on that gets past a lot of this. So that's been very helpful. The other thing, if you deal with adaptation instead of mitigation, if you say, I don't really care who's causing the problem or how it's being caused, all I care about is what it means for your constituents. Then I can go downtown and I can talk with, for example, the secretary of the DNR and say, this is how we should be doing this. And they say, yeah, that's great. That's a great talking point. And we need to be using the best science available to be adapting. As long as we know that mitigation is far more politically charged than mitigation.
Break. All right.
I'll
Thanks.
talk to you afterwards. Yeah.
Okay, yeah, definitely. So we're gonna take a break here. We're gonna make it 10 minutes since we're running a little bit behind schedule. So we'll start again in 10 minutes, and we're gonna delve more into broadcast meteorologists, the questions they have, and the communication challenges that we face, and solutions that are out there for broadcast meteorologists as well. So again, we'll resume in 10 minutes. Thank you.
Dan, do you want to explain the bathroom situation?
Yes. Women's room is on this floor, and it's exactly kitty corner from this corner of the building. And then men's room is one floor up, same place, kitty corner. There are stairways in the middle of the hallway, right where you see exit right here. And then on the other side, there's a stairway. The 7th floor is all AC units, so don't go downstairs. Yeah.
All right.
You can't get to the 7th floor. Yeah, that's where we're under where people who fail with walls.
Oh, thanks. Thanks.
Hey Sean, how's it going?
And it's why it's working out. It's so simple. No.
Area, this thing is expanding and contracting, certainly within a year. Is it happening over a series of years? That's right, that's it. We haven't seen it
Get up, there go the door.
So we did actually. Oh, yes.
I can hear you now.
I know.
No, I still do that. One.
Sorry, I lost it. What's that? Oh, you're looking at yourself,
Yeah, sure, I'm aware of
Yes. Okay, so I'm gonna kind of readjust the laptop to face the audience,
and the energetics of that just.
I guess Rob's gonna talk for a few minutes and then switch over to you. Okay, sounds good.
You would have to.
Yeah, no problem.
In addition to
All right,
needing
sounds good.
all of our, so one, energy demand is increasing far more rapidly than the rate at which conversion is going. Even though that rate is large, the demand is increasing at a rate that's even faster. And so in the near term, we're not going to go to that in the next.
Oh, man, it's getting dark.
In terms of removing carbon dioxide from the atmosphere.
Well, I know, based on our current.
Yeah, but even in the future, thermodynamics, you have to.
Yeah, I know, but they would tell you,
Yeah.
don't worry. I mean, that.
Yeah.
They would say, don't worry.
That was great.
Hey.
Nice. I think that's a really nice.
So there's a lot of stuff coming out of this department around the city. It's really informative.
Yeah, that could be. I don't.
But anyway,
I don't.
I know.
But the flip side is a lot of people are a lot more concerned. I see no relevance.
Well,
It already is.
Can't believe that.
Sure.
Mitigation.
So great. It's really cheap to dump stuff in the stratosphere. It's like $20 million a year to offset. But it's like,
I noticed it was right.
Yeah.
Yeah. Or that technological.
Yeah, the other thing,
Incomprehensible.
the problem is that carbon dioxide, the lifespan of carbon dioxide in our atmosphere,
I didn't realize we were.
in terms of being absorbed by the ocean, it's so important, it's 50 to 60 years. Once that comes into the ocean, the lifespan of carbon dioxide in our atmosphere is 10,000.
Yeah.
So whatever's here, you get that. Yeah.
That's what I did. I
Yeah.
just-
Obviously, that's without.
Yeah, I don't see.
I know, it's very hard to see, isn't it? I know, it's very hard to see.
And yet, you know, I mean, you look at, but the other thing is, the guy who's machine learning AI,
It's just like, I don't want.
a friend of mine went to Gonzaga in 2001. He made my apartment in that time, 2001.
Yeah, I see.
So,
Is that the person who knows your story?
Yeah.
Yeah. We had our, was it October 20th? Yeah, we had our student too. But that looks like. Oh, that's Yeah, and this week gets colder and there's a big lake effect.
That's what I want.
On the leaves, many lakes, I don't know if maybe it's Oh, yeah, okay.
I don't know. See the effect.
Yeah. I think when the really cold air comes in, it'll be more this more dress. That'll mean the sun. Oh, yeah. Yes. Me too. I love it. You know, I meet you in my minority. Everybody else looks at it. I just love it. Oh, did you? Yeah. I don't know. It seems to me, I don't know what happens after the 10th or 11th.
It's small school.
We've got a lot of rushes.
My
Cold
generation.
there for this early in the year. Maybe we're gonna see a bit of an early snow. But even so, it's coming up mid-November, so that's the first time we get that 50 rain or snow line.
It's fun to,
Yeah, when I get to this time of year, I get really excited about the prospects. I feel late and disappointed in most recent years.
That's why I have
Yeah. Never get me going. Late by when I was a kid, there's snow changing. That almost never happens. It's either gonna start to snow and stay, or it's gonna take it. There's no false every time. That's a major. And the nature of these businesses, recreation businesses, even those that just sit in housing, is it's all these explosions of activity in the off season. You lose all those explosions. Would include wintertime weather, so that's something to do with you know, interesting side project. The data might already be available for you. I'm thinking that's that related to what September, October, November. That's when all the heat extraction is on and coastal water. And it might be true that given otherwise normal January and February, it depends on what happened in the early part of the pool season to get the ice thick enough to let the water. You might know that you have a 60% probability in Germany versus a 20% probability in Rainfall. And just, you know, you can at least take some sort of adjustment in your model. Yeah. How fast can you relax? How influential? Which of the two is more influential? December, January, early February, or September 1st, December 11th? In setting that really probably want to do it with yeah, they are. There's no lack of questions. No, me too. If it gets my mind focused on the prospect of cold, I'm really happy. Yeah. That's right. Looks terrible.
Okay, folks, if we can get seated, we will get started again.
Hey, Bob's too polite to tell you to be quiet and sit down, but I'm not. This is my home field.
Excellent.
Everywhere.
Okay, wow, wasn't that great? I mean, I learned so much in that period of time from our three climate scientists and from Kim from the National Weather Service. I go out and give talks, and some of the science I'm strong on, some a little bit weak, and this definitely helped fill in some of those weaknesses when I give a presentation. Just briefly, how I got to this point. About 2 years ago, I decided I have to do something. A lot of people have been involved with climate science education longer than me in the broadcast field. But for me, it was about 2 years ago. I said, all right, enough's enough. Time to do what I can and start communicating. So I started doing that first by giving talks to groups, civic groups, church groups, all kinds of different groups. So it's kind of grown from there. And I joined the Station Scientist Committee in January, and that has evolved to where we're sitting right here today. So I'm going to give you a presentation. Some of it just involves my personal experience, and we'll expand from there with other TV meteorologists that are in the room right now. So we'll get started. When it comes to the national media, we can't rely on them to help us out. If you look at this is last year, 2017, the number of coverage minutes by the four networks. 57, 49, 97, 68. Generally less than an hour of broadcast news coverage of climate change events, but it was dominated by covering what Trump was saying about climate change. It was not talking about what's really happening. It wasn't talking about solutions, anything like that. So total minutes of climate coverage is in pink. Minutes of Trump administrative related climate coverage, you can see, was dominated by coverage of President Trump and what he was saying. Which topics did corporate networks address in their climate coverage in 2017? So the combined nightly news and Sunday show segments of the four major networks. Again, it was dominated by coverage of President Trump's administration's actions and statements. Extreme weather events in the United States. There were only 4 topics covered. Public health, 4. Economy, 3. National security, 2. It doesn't get any better if you look at other things here. Broadcast news segments that were discussed as a link between climate change and the extreme weather events in 2017. This is it. Pink is for extreme events and for other countries in blue. ABC, My Network, 1 last year. 1 story. CBS, well, 2 when you take into account there. 3 for CBS, 1 for NBC, 0 for Fox. Thank goodness for PBS. They by far dominated in terms of covering climate change and from a real scientific perspective and not from the political perspective that the other networks are doing. So the national networks have failed in covering climate change as a science and letting the public know what climate scientists are saying. They have not passed that information on. So that's where it comes to the local TV stations and the local meteorologists. Our strength as TV meteorologists is communicating complex concepts in easy to understand terms. We do it every day. Our main job is to be the nice, friendly person folks invite into their homes. But given the number of Americans that are skeptical, we need to get the proper science out to the public. We just have to be careful not to mix too much physical science with political science. That's poison if you go towards the political side. We are as close to a scientist as Americans will ever get. We can help educate our viewers. How many times have we heard about this? What am I doing? I'm shoveling 36 inches of global warming and various stories along those lines. So again, we are the scientists for by far the majority of the viewing public. We come into their homes. There's a level of trust with us that they don't get otherwise. I would love it if Dan and Kur and John could do a special climate segment every show, let them tell the science. But of course, that's not reality. The reality is it has to come from us. We are as close to a scientist as Americans will ever get. We already help to educate our viewers. This is from Max Paris, who was just here a short time ago. We have our Sears weather blog, and he was talking about sundogs. We talk about science a lot in various forms. It's just a matter of making climate science a more integrated part of our presentations and covering it more frequently. We are as close to a scientist as Americans will ever get. We must help educate our viewers. Absolutely must. And I think this cartoon just summarizes everything, right? We are slowly being cooked in a pot. We're slowly being boiled in a pot. See, there's no consensus as the frog slowly boils. So it's absolutely incumbent upon us as broadcast meteorologists to bridge that divide between what climate scientists are saying and what viewers are getting in that distorted world of TV and internet. Because when you Google climate change or do a search engine on climate change, so much of it is disinformation. It's so important for us to be there to give them the correct science. And there's a level of trust there that they don't get otherwise. I found this interesting. Public trust on the topic of global warming. It's back to 2015, so there's some older names. Climate scientists, you're up there, number one. Strongly trust dark blue, light blue somewhat trust. Never heard the answer, somewhat distrust or strongly distrust. So family and friends, second. That's why when I give a talk, one of the things I tell people what they can do as when they leave the talk to your friends about it, because that really does carry a lot of impact. Number three is other scientists, not necessarily climate scientists. There's television reporters, weather reporters, or broadcast meteorologists, number four, just ahead of the primary care doctor. I'm not quite sure how primary care doctor got in there. I can't just picture myself being talking to my doctor about climate sciences, as they do an exam of some kind. But bottom line here is climate scientists or television weather reporters are up there. So we do have this level of trust that we have to parlay and use. Broadcast meteorologists are uniquely positioned to educate the public about climate change. We are, in fact, trusted sources who have extraordinary access to the public. We tend to be highly talented and well-engaged science communicators. We are very active and access new and effective communication platforms not often reached by climate scientists. That's one thing that we've learned in the television industry. 10 years ago, it was just go on TV, don't worry about it. In the last decade, the social platforms have just taken over. And so we've had to learn how to use social platforms in a very effective way. And if anything new is coming down the pipe, to use those as well. TV weathercasters' views on climate change appear to be evolving rapidly. And you saw some of this before. I think Corey touched on this a little bit. More than 90% of, this is again from the George Mason University. This is the 2017 survey, so the latest one. More than 90% believe climate science is happening, and approximately 80% that human-caused climate change is happening. This has increased substantially in the last 10 years. It's been increasing at a rapid rate. 62% believe that climate has changed in their communities over the past 50 years. Nearly 60% are at least somewhat interested in reporting on air about projected climate change impacts. 77% are interested in reporting on a range of local impacts. Nearly half have indicated that they have reported on the local impacts of climate change on social media. Now, it says nearly 60% are at least somewhat interested. Interested does not necessarily translate into doing, okay? But these numbers are encouraging. They have increased. We're seeing that more and more with broadcast meteorologists. They're more willing to do something and communicate. As this overwhelming burden of climate science descends upon us. Barriers. Okay, so what's holding things back on reporting climate change? Lack of time to prepare material. That can be a problem. We're busy every day with our normal jobs. Lack of presentation time in their broadcasts. We have generally between 2 minutes to 3 minutes to do our whole presentation. And we always want to make sure we get the why of what's happening in our forecast. So we got to get it in addition. That means usually doing it on quiet days when we have a little bit more time. Not enough knowledge about climate science. That's a significant one. You don't want to go on air and say something, and you got to know inside and out, because you're going to get questioned about it, and you're telling a lot of people. And because of not enough knowledge, a lot of times they're just simply not comfortable broadcasting about climate change. These are significant too. Resistance from management. And that's a big one that I've found as I've been talking with other meteorologists of what's holding them back in communicating. Fear that their viewers will complain. We get enough complaints when we have to do a tornado warning during primetime coverage, and fear they'll literally lose their jobs. It's easy for me because I've been around for a long time. For those just breaking into the business, just trying to get established, they can't risk doing something that will affect that. So my story when it comes to this is resistance from management, okay? I assumed that my management was going to be resistant. Lo and behold, I found they weren't. Now I'm lucky. I'm lucky at my station. They are very accommodating on talking about climate change, talking about it on air, going out and giving talks, and the like. Fear the viewers will complain. I remember the first time I did a discussion about climate change. I rarely get nervous. I've been in this business for a long time. I was super nervous when I first talked about climate change on the air. You got to get over those obstacles and those things. We have the AMS, the American Meteorological Society, definitely has our backs. This is their statement on climate change. There's unequivocal evidence. The Earth's lower atmosphere, ocean, and land surface are warming. Sea level is rising, and snow-covered mountain glaciers and Arctic sea ice are shrinking. The dominant cause of warming since the 1950s is human activities. This scientific finding is based on a large and persuasive body of research. Of course, it's the AMS and every other scientific organization out there, right? But the AMS does have our backs. At the station, again, we're lucky in the fact that our management recognizes the problem and they recognize that communication has to occur in climate science. It went to the point where they did a documentary a couple of years ago. Greg Jeske, one of our news anchors, did a report called Our Wisconsin, the Climate Change Effect. He did a really good job. He started off with the assumption climate change is happening and what are we going to be doing about it? And he went from there and called our various politicians to the carpet in the state and did an analysis. So I just welcome you to take a look at that at some point. It was well done by Greg. Okay, that's my part. I think before I take questions, we're going to go to Sean Sublett, who's part of Climate Central. Because a big part of the problem a lot of times is finding time to go on the air and present, doing a nice graphic. Well, Climate Central, as many of you are aware, does the job already. Sean, can you hear us?
I hear you guys just fine. Can you hear me okay?
Excellent. So Sean, I just went through my presentation and I just introduced you and discussed the fact that Climate Central is a solution for TV meteorologists to put material on the air. I'll let you take it over.
All right, Bob, thank you very much. And thanks everybody for coming out this Sunday afternoon. I'm here from my little townhouse in suburban Philadelphia. That's one of the wonderful things about telecommunications. Our office is in nearby Princeton, New Jersey. And basically our job is to help you communicate climate change to the public. That's kind of what we're all set up to do. We're nonprofit, we're nonpartisan. We have a mixture of private, public funding that helps us put the message together. My particular part is largely a National Science Foundation grant. And I just want to echo all the things that Bob said. I did TV right up for 20 years in Western Virginia until about 4 years ago. I decided that this was important enough where I needed to take my career in a different direction. But I had all those same concerns that Bob did 5-6 years ago. But I can absolutely echo what he said. There's a sea change going on in the desire to communicate the science to the public from the broadcast meteorology community. So I'm going to share my screen here and go through some of my slides and show you what we kind of do here at Climate Central. You guys have the screen up?
Yep.
Fabulous. Fabulous. All right, so off we go. So there it is. Tools to help discuss a changing climate. Let's talk a little bit about how the public is viewing this. This is from the Yale Climate Opinion Maps. These are updated every year. You can go to the website there, climatecommunication.yale.edu. This is a wonderful resource to see how people in your viewing area, in your state, in your congressional district, envision climate change, whether they believe into it, their risk perceptions, whether they enough policy, all of those things. So in climatecommunication.yale.edu. But the big takeaway from this is that most people across the country do believe climate change is happening. I'm kind of moving some things on the screen. I apologize if I'm looking away from the screen a little bit. But most people think global warming is happening nationwide. Still, a small majority think it's caused mostly by human activities. But here's the thing, the third one from the top is where there's still a lot of work to be done from the communications aspect. That only half of the public sees the dominant consensus from the scientific community that the planet is warming due to greenhouse gases and fossil fuels for humans. Only about half of the United States sees the 97% consensus. You can split hairs there, but it's the overwhelming consensus of scientists, climate scientists, that see what's happening. And it's funny that you actually see there's a large number of people that think it's affecting the weather, even though they're not all in agreement that there's a consensus. Now, even though there's still, a little bit more disagreement about causality, et cetera, there is still widespread support for the solution. You see this, the policy support for renewable energy sources, regulate carbon dioxide as a pollutant. Those are much, much higher than just the causality arguments in the first place. So when you're communicating, even if you don't feel like saying, well, this is caused by humans, et cetera, if you talk about solutions, but for the most part, we're talking about renewable energy. Most people respond very positively to the concept of renewable energy. Not always because it's good for the environment, but there's a subset of people, some of the research has suggested, that just love the idea that it's renewable and it never runs out. So you can focus your messaging, if you will, around the positives that go with those types of solutions. And I know we're in the space where we do this all the time. I mean, Bernadette, who I work with at Climate Central, this is something we deal with every day. And I know Bob deals with us on a regular basis. All of us in the weather enterprise deal with it. But it's important to remember, as sick and tired as sometimes we can get by talking about it, the public still hears way, way less of this. As Bob said, there's almost no coverage in the national media. So it is kind of up to the broadcast meteorologist as a scientific liaison to the general public to get the best science out there possible. Because as the old expression goes, if we don't do it, somebody else will, and they're going to give bad information. So it is kind of, the onus is on us to get the good information out there, get the most solid science, the most scientifically accurate information out there as possible. That's our job, is to help you with that, with the pretty pictures, which I'll show you about in a minute. But we also know that every community is different, whether it's Madison, Milwaukee to Eau Claire, or down to the Gulf Coast, the West Coast. Every place is a little different. And those people who live in their communities, interact with the public on a regular basis, know much better than I do in Princeton what's going to work in their community. I just want to go into Madison real quick to show you from the Yale Climate Opinion Maps. The national average is only about half of the people who understand the consensus, whereas locally there in Madison, it's a little bit above that. So it's a good majority of the community in Madison understands the scientific consensus. But there's still a little bit of work to be done there. And one of the other things we like to remind people is that there's so much noise, and you all know this about the science. But it's not just believers against the minors. There's this real, and we see this in the national media, one or two, it's off, it's binary. And it's not really binary. The ones on either ends of the spectrum, if you will, and global warming 6 America, tend to be the noisiest. On the left there, those are the ones that are most alarmed. They are the ones that are on board. They understand what's going on. They're ready to take action. They're there. And you kind of take the spectrum all the way to the right, and those people that dismiss what they just have nothing to do with this at all. They're absolutely convinced it's a hoax. They're going to just only await every single opportunity, and they tend to be the most loud, whether it's social media or whatever way they can to just make a lot of noise in the opposite direction. So you see that there hasn't been an awful lot of change in that spectrum. If anything, it's maybe nudged a little bit to the left, showing that there's a little more cautious, a little more concern. But there's also been a tiny increase in the dismissals. But one of the things I've noticed from this between 2009 and 2018 is the number of disengaged has dropped tremendously. So we do see more people, unfortunately, kind of going to either side of that spectrum. Now, a little bit about what we do at Climate Central. Our program, the program I work on with Bernadette, it's called Climate Matters. It's basically set up to help broadcast meteorologists make that connection to weather and climate. We've been putting these packages together every week since about 2012. And each package comes out once a week in the email on Wednesday mornings. They have some kind of analysis. Most of the time it's local. Sometimes it's national, sometimes it's global, but the idea is we're trying to do a local analysis with some data, some kind of a narrative, and some kind of cool picture that you could share in a quick 5, 10, 15-second part of the weathercast, and you just kind of continue on. So if you look at the top left, you see more summer hot days. In other words, we have more days that are above normal now than we did about 50 years ago. So if in the middle of a heat wave in Madison, you can, hey guys, it seems like it's been getting hotter. You're right. Here's what the data showed over the last 50 years. We've had a lot more summer days that have been above normal. In this case, normal is chronological normal, but continue to 2000. And that kind of stuff is down there in the footage. We're always doing the best science that we can and the time allowed, turning these analyses every week. We have methodologies in these emails. And if you ever have a question about what we do, how we do it, you message me, email me, call me, I'll have all that stuff there at the end of the presentation. There's a lot of issues with sometimes, well, the graphics don't look right, I don't like the title. Well, we also have versions of the graphic. Those top two, we can take the backgrounds away, we can take the title away, so you can more easily incorporate those into whatever kind of background you want with your sort of broadcast meteorology. We also will occasionally do interviews. I can do a Zoom, Bernadette can do a Zoom, we can Skype, we can do a soundbite for a story, or if there's another piece of information you want us to go look up, we can do that. We can also help sometimes connect you with the climate scientists nearby, but most of the time you just need a quick soundbite and we can help you out with that. There's some more versions of the graphics. We don't do strictly analysis at the time. We try to do things that also are focused on impacts. As Bob told you, everything is local. Local people want to know what it means for them. So, for example, more carbon dioxide means more pollen. We've got the carbon farming is a way of, it's the no-till farming. You're not tilling up, you're not piling up as much carbon out of the soil as into the atmosphere. You're holding more carbon into the atmosphere. And then just, the benefits of trees, for example, taking carbon dioxide out of the atmosphere. Those specific numbers are for Madison. In other words, how many, what the trees doing in the market area of Madison. That's stuff from the EPA. So all of our stuff is very referenceable. If you have any questions, we encourage you to let us know. These emails go out once a week, and then after they go out, within about 30 minutes, we put them on our media library. It's a searchable media library, like keyword there. And there's the website to go, medialibrary.climatecentral.org. This stuff is free. You don't have to pay anything for it. Anything we ask you to do, if you find a cool picture and you share it, let us know. Give us a little credit for it, either verbally or on the air, so that we know that it's being used, because that's also very important, because it said National Science Foundation is part of this, and at the end of the National Science Foundation grant, they want to know what we've done, so that actually helps us out a lot. But every week's release is right there. You can search by topic, whether it's heat, drought, fires, tropics, heavy rain, flooding. We've taken a lot of these releases and put them in these special toolkits, which you can also find there at the Media Library website. So if you're in the middle of a heat wave, you can pull up all of our material on heat. If you've got a heavy rain event, You can put all of our material on heavy lift. Coastal flooding, obviously not as much of an issue there. In Madison, more wildfire, that's much more involved places on the west coast. But if you run against the drought, we could talk more about how drought is going to change. We do occasional workshops and webinars. Workshops kind of like this, sometimes we'll come and help out somebody who's putting together a workshop like Bob is, or we will put together a workshop where we can invite our people along. We also do these webinars about 6 or 7 a year. We bring a climate scientist and kind of basically we give you an opportunity for those of you who are looking for continuing education points, whether you're AMS or the NWA, these count towards education requirements to renew seats. We've got a couple of them that are coming up here actually just later this month. And as Bob alluded to, there's the next two that are coming, the next two webinars, running about a week or so. I believe Isaac and Duke is going to be talking about financial costs of climate change, responding to the economics of climate change, what's going to cost us, what's going to cost us in the future. He's an economist as well as a policy analyst with Duke. And then I think most of you have heard of Catherine Hayhoe, who's at Texas Tech, who is an excellent climate change communications person. She's giving our webinar at the end of the month to preview the 2018 National Climate Assessment. So, with Dean and me, and I can get you the links to those hopefully tomorrow morning. We also have a turnkey outreach presentation. As Bob said, and I started doing these too, we go out and talk to the community, the Lions Club, the science, schools, whoever. This particular presentation is more aimed at adults rather than for the fourth grade talking to kids about weather. But it's exactly 50 or 60 slides, all with data about climate change. And there's a section of it at the end where you can customize it to your particular market. There's Madison, Milwaukee, Green Bay, wherever. If you ever need help with this, send me a note, we'll help you get you set up. We update it once a year. Once we get to the end of this calendar year, I'll have the opportunity to make some changes with the 2017 data. We like to do some fun stuff every once in a while. Halloween, we just mentioned Halloween. This is the graphic that we put together for Halloween. We couldn't call it a Ouija board because it's copyright infringements, but you kind of get the idea. Here we talked about the time extremes on Halloween for Madison, and then we looked at what the average mean temperature is in Madison for October since 1970. This program we started 6-7 years ago has grown tremendously. We now send out our fund in Madison 617 meteorologists across the country. We're in 161 of the 210 media markets. In fact, we're in all the top 7 media markets except for Indianapolis. Email me, eventually we can get you all set up. To show how this program has grown since we started in 2012, it took a while to get the sea legs, but as I think as Bob alluded to, is the meteorological community really begins to understand what's going on, how the science continues to strengthen. We get a lot more play, if you will, of the materials we're sending out. So these are the television hits that we've been able to find in Google and total social media, with Twitter and Facebook, as well as television hits together. We've already exceeded all of last year. So we're very happy that the word is getting out. We tested this little clip earlier on. We're not sure it's going to work regarding the audio. And Ferd, did you want to try to play the audio from there?
Yeah, so I'm gonna go ahead and just play it locally, and then we'll.
Who's going to play this clip from Mark Henderson down in Rockford?
We'll look at the beautiful fall colors that are being sent to us daily by the good folks over at Clem Arboretum. It's a yellow buckeye here showing those colors, starting to get closer and closer to the peak by the day. In fact, I think just a matter of a couple of days away from the peak. Now, a lot of folks have commented that it seems as though the fall colors are being delayed a little bit this year, and really not just this year, but in recent years. And it is indeed very much the case. And we think that climate change may very well have something to do with it. Now, there are three factors that play into fall colors. Rainfall, if there's too much or too little, can either delay or accelerate the process. For the most part, it has been pretty close to normal, all things considered. Temperatures, if they're really, really warm, that will certainly cause a little bit of added stress on the leaves. If you get into a period of sunny skies and drought, you may not see the leaves produce any color whatsoever. Now, that has not been the case. So all things considered, we've seen near normal temperatures and near normal rainfall, although it has kind of been a little inconsistent. But if you look at the overall trends over the course of the past 45 years or so, those temperatures are warming in a big, big way. You need those crisp, cool nights to see the colors really start to take form. And as our nights are warming here and warming steadily, it just delays everything. It delays the end of the growing season, unfortunately, and we've seen this be the case this go around. It delays the end of the allergy season. We were dealing with allergy concerns well into the month of October before we finally got a bit of a freeze. So kind of interesting.
So yeah, that's a bit of a longer one. It's a bit of a longer segment. But sometimes you're in a quiet weather pattern and you have a little bit longer to devote to something that's very top of mind, like the fall foliage. One of the things we've just finished up here within the last couple of months is a wind and solar forecaster. It's a long-winded URL there. But basically, we worked with an energy forecasting organization called MESA. And we've been working on this since last winter to put together an operational solar and wind forecasting tool to let us know how much electricity is generated in your market by solar and how much can be generated by wind, depending on how many wind turbines are in your market or in nearby markets. Because the reality is most wind that we do is generated locally, is kind of generated somewhere else and brought in. And the algorithms are complex. We have a full methodology written up, and this isn't meant to be strictly precise down to the kilowatt hour. It's out there to give you a good sense of what the capability and the possibilities are, depending on what the weather situation is given the time of day, or given the success of things. Briefly, before we wrap up, for your colleagues, we started something new called Climate Matters in the Newsroom. It expands on the weekly Climate Matters, which right now is more focused for meteorologists. This thing comes out once a month, but the topic is in more at journalists and also provides new resources and tells more of a local climate change story, but not necessarily a weather report. So this is something that you could share with your reporters or anchors, and it's really easy to sign up. You can put it in the notes and get these things out. Some opportunities coming up, to talk about this stuff. Major holidays, anytime there's extreme weather, recurring seasonal activities and sporting events, and anytime you have a chance to really drive home the impact of health, economy, agriculture, or big government reports come out like the NCA, which is coming out next month. And just to go back to what we said at the beginning, solution stories are almost always positive, and they have widespread support across the ideological spectrum. So I know there's a concern, there's worried about kicking off somebody, a certain side of the political spectrum. These are the kinds of things that have widespread here. There's my contact information. We'll leave that up there. You can email me. You can @ me, as the kids say today, on Twitter. If you follow us on Facebook at climate.matters, you can see examples of people using it on the air. Again, we have 600 meteorologists who did this, and we have a good 100, 150 that use it very regularly. Some people obviously are going to use it more than others. We understand that. Everybody has their own limitations. But you can see some good video examples of climate matters doing this. So I'll stop there, and I'm happy to take some questions for everybody who runs off the game.
Great. Thank you.
Any questions for John?
Yeah, Sean, just really quickly, about crediting you, because I report a little bit as well, so like in packages, do you guys need like a separate accreditation, if the Climate Central logo isn't on there?
You hear that, Sean? Accreditation?
I didn't hear all of it. It was just how do you want to do credit?
Right. If their logo is not on the graphic that they're using, about accreditation.
Yeah, I mean, you could say anything will do, just, according to data from Climate Central. If you prefer to have a logo up there, sure. But if you don't want to have the logo up there, just say according to data from Climate Central, or according to an analysis done by Climate Central. The data we use, we're almost always getting from NOAA or somewhere else. With the Applied Climate Information System, which is also NOAA. Most of the data we're using is NOAA. The trees thing that you saw earlier, that was from National Forest Service. So we're always using publicly available data with very little exception. So you can say the data is public, the analysis was done by Climate Central, an analysis done by Climate Central, something like that. It's fine. And if you end up, if you or a reporter actually does like a 60 or 90 minute package on this, and you get that in script, this Climate Central somewhere in script, that helps us find it easily for our third-party tracking. So we can kind of archive that for our internal folks.
Sean, Gary Canelti here. Thanks again for what you and Bernadette do for giving us the graphics. Quick question for you. We're kind of fortunate, I guess, in a little regards in being in Madison, in an area that's a little more liberal and people understand climate change a little bit more. How about in some of those more conservative areas of the country? Are you finding any blowback from stations yet? Where politically they might not be as receptive to more information on climate change, and how are you working with those stations?
Well, the way to approach that is, as you said, meet them where they already are. We can talk about solutions because there's widespread support solutions. Even if you just say the word climate change, that tricks some people already, they turn you off. So you can show the data and not necessarily say climate change. You could say, if it feels like it's been warming over the last 20 or 30 years, or since you were a kid, you're right, there's the data that shows it. And if you approach it in a way that isn't going to immediately turn them off, they will tend to be a little more open to it. And I'll drop names here. Jay Prater at KAPE. What's your thought? Jay's a good friend of mine who's conservative. We've talked a long time about how do you do this in a conservative area. And we just have to be very careful in the messaging. We don't want to start on words that are going to turn people off. If you do this this way, then you'll probably be right. That kind of messaging tends to work a little bit better. Something that's certainly not preaching. Meet people where they already are, with all the different people experience.
Other question? Thank you very much, Sean.
Thanks, everybody. Appreciate the invite.
So just to follow up a little bit on Sean, for those of you that are thinking about perhaps making that first step in climate change education to your viewers, I would keep a couple of things in mind. Number one, you're not alone. You do have Climate Central, you have Sean, you have Bernadette. They're there. You can email them and they'll give you ideas on what you should do in your particular situation. You have the Station Scientist Committee for the AMS that you can communicate with as well. We're more than happy to mentor meteorologists that are trying to make that step as well. So I just want to keep those things in mind. I know I'm lucky to be part of a station that lets me do my thing. I'm in Madison, but there's also various levels of resistance depending upon your station. But don't make assumptions. Make sure that you do talk to your management and see where they stand in regards to you doing communication. You might find that you're limited to social media. They won't let you talk about it all on air. But hopefully social media you can get on, you can blog. There should be some level of communication that you're able to do. So that's it in terms of this presentation. Were there any questions for me before we bring everybody in?
Yeah, I had a question, Bob. You've been at it for a long time, and I'm sure your job is for all those years involved presentations to the local community at a variety of age levels. And you mentioned on one of your bullet points, fear of, frustration by viewers. Have you encountered that as you've embarked on this when you go on those outreach opportunities to the community?
Yeah, that's a good question, John. How much pushback do I get from the viewers, much less management? And I was all afraid about all the pushback I was going to get, because it seems like those first couple of times that you get all the feedback, then as you're on there more and more, you don't hear anything anymore. And I did get a lot of feedback the first time that I discussed climate change, but it was overwhelmingly positive. Now, of course, I'm in Madison, right? So I'm sure that skewed it to a large degree. When I'm out talking in the public, usually I'm preaching to the choir, is what I'm finding. I don't get a lot of people that are pushing back on the science. That I wish I had more. I'd love to engage them a little bit. But, I think a lot of the problem is a lot of people are on the fence. They don't know one way or another. They hear both sides, so that's where our job is, to get them on the right side of the fence so they start enacting and doing some action. Because right now, the special interest groups, all they want you to do is have no action. And by having enough doubt in your mind, you're not going to do it. The last thing I want to bring up is that when I gave my talks, I would finish it kind of like Dan Vyman did. It was very depressing, all that negative climate information. And I would end with, well, what can you do? Well, reduce your carbon footprint, go through those steps. But that wasn't enough. So personally, what I did was I looked at what kind of solutions are out there that I can pass on to the public in terms of what we can do to enact a faster solution. So we're not on that red line, going up towards 6 degrees, where we can level off that projected temperature. And I found that number one, putting a price on carbon is the thing that has to happen to level the playing field so that the renewable energies, which are right now somewhat better, are so much better in terms of being cost effective. And in particular, when it came to carbon, putting price on carbon, I found carbon fee and dividend. I think it's the way we have to go. And I joined, it got to the point where I joined an organization called Citizens Climate Lobby. And they're an amazing organization. I encourage you to do a search engine on them. I have the ability in June to actually talk to, go in the offices of our 2 senators and speak about climate change and about solutions. How often do you get that opportunity? So I had that chance. So we have a representative here, Madeline Para. If you want to talk further about Citizens Climate Lobby, she's there for you. Anyway, I want to make sure I got that plug in. Any other questions before we get everybody up here to see if there's any more questions?
How do you translate to students like your STEM and STEAM talks at a 7th grade, 8th grade, 9th grade class level?
How do we translate this science?
Like the future to
Yeah, if you're in the business laws I have, and a lot of these other Mets can relate, we've been giving talks about weather all along. And so we've had to make that translation. How do you talk? I mean, really, what I found is when you talk to a 2nd grader, it's no different than talking to an adult. You're given, they absorb the same amount of information, but you do have to be careful about making sure you bring the science to the proper level. And again, I think the Climate Central graphics really help in that as well. Yes, ma'am.
Could I just amplify just a smidgen what you
Sure,
said?
please.
Just a couple specific thoughts of where Citizens Climate Lobby might be able to be helpful to you if you venture into these waters. And we love Bob. We'd like to have more Bobs. But not everybody has that kind of support under him. But if you're venturing into speaking about climate on air, and we have 18 chapters around Wisconsin and hundreds others in the country, and we hear it, the odds are very high that you will get a flood of thank yous to your station. If you happen to let us know you're doing that, the odds are even higher. And we are not the part of the movement that screams and yells and protests. We are very focused on making climate right now. Our message to Congress is make this a bridge issue. We need to come together on that. So I could say more, you're welcome to talk to me, but I just wanted you to know that we will go out on, do what we can to support you when you venture into those waters, if we know about it.
And she's done that. The CCL has done that for me when I've spoke. They've sent emails to the management. As you know, management really watches all those emails that they get in from the public very carefully. And so it can have a big impact in making sure that you can continue to get the word out and maybe expand what you're saying a little bit more than what you are able to do right now. Yeah. Excellent. Well, we're running a bit behind, but we definitely want to make sure that if there's any other questions that we get to them, because we have Vancouver here, we have John, and we have Dan in the back. And we have Tim as well. So does everyone want to just come on up front? And well, maybe there's no questions, I don't know, but I want to make sure that we get everybody's questions answered before we wrap this up. So anything out there, or did we cover everything in terms of, go ahead.
Well, just one with all the group here. One of the sticky things I do, I write articles for weather.com, so I cover weather events and for about 2 years. And one of the stickiest parts is attribution. And by attribution, I mean I'll just give you a little background. I was a meteorologist I worked with, still Weather Channel 2 Austria. And in December of '99, I believe, there was a bizarre severe weather event up in Pennsylvania in December. And from that point forward, we started capturing every bizarre out-of-season weather event into a PowerPoint presentation, which is now hundreds and hundreds of slides long. Just showing you 500 millibar anomalies. And it said, this is weird. This is severe weather in Pennsylvania. So my question kind of for the group is, we have world weather attribution now, which tends to look at these extreme events, Harvey, some typhoons, and put them in kind of a climate context. What loading the dice climate may have played a role with in those events. So when they do those events, it's great for us because then we don't seem to have guardrails on a lot of these events in a climate context. So one that came up to me is the September 28 Dane County flood. So I guess what I'm asking is there, I struggle with that, because we said, okay, here's another part of the story, but there hasn't been an attribution done, and it's one weather event, it's one weather event. What can we say from a climate context? I guess I'd just like to get your thoughts on how, to what extent we can take some of these other events that may occur on a regional scale that may not get as much national attention as, say, a Harvey. To what extent can we discuss that in a climate context?
And just for our live stream, it's about attribution, especially doing attribution more locally on a regional basis, besides the attributions they do for the major severe events.
Well, and in real time too, right? So.
I think in terms of from a scientific perspective, it's a difficult problem. The approach I think has been really useful has been to say, this is consistent with the kinds of events we might expect in the future. And then the second, which is not very satisfying, but the second part of that I like to say is that how much of this was due to climate change or not is not as important as what we can learn from this event and say, we saw flooding on the isthmus. What are the things we could be doing as a community to be more resilient to these kinds of things in the future? And those are the kinds of conversations that we should be having as a community. So to kind of, divert? Is that what it's called? When someone asks you a question, you answer a different question. And kind of divert in that sense and talk about kind of what we can learn from the
in my experience with Steve Ackerman on the radio, and it's now 20 years of experience, we get this question occasionally. And I very much agree, Dan, with your first point, is that one good way to handle it is to say, this is the kind of event that fits into the umbrella of events that seem to be on the horizon, and it may be an initial harbinger. But it gives a great opportunity, instead of diverting, which is also a reasonable strategy, to sometimes have a confluence, which you say, but here's why we're still a little bit skeptical about making such attributions of individual events. And to me, that conveys to a public the fact that scientists are conservative in what they're going to say. They're not going to just leap at the answer, which sounds, the most sexy and the most likely to generate the most hubbub in the media. Instead, it's a very conservative approach. And it's fair to say from that conservative approach, hey, that, you know, a tornado in Wisconsin in February, which is nearly unprecedented, is a little bit unusual, and we ought to think about how that fits into what might happen in a future world. But we're not ready to say that this tornado is a result of climate change. We just don't know enough to say that. And I think it's two wins instead of just one. The first point's true, but the second one is an opportunity to reinforce how conservative science really is. So that when conclusions come out with confidence, you should believe them, because they've been hammered on by people for 10 years or more, and with a lot of people studying them. So anyway, I feel it's an opportunity to drive that point home, somewhat subtly.
But what about, I guess, to me, is when you hear an attribution done for like a hurricane that was just occurred, like you heard about that for Florence.
Right.
Any feelings about that? I was a little bit nervous that to even mention that kind of attribution.
I saw the visualizations, right? They said, well, you know, we ran it the same model without sea surface temperature. You know, if you brought it down a bit, and it does call into question, like, you know, I think John's right? Express it as a notion of like consistency, conservative science. I did think there were some great visualizations, though, from, for example, the storm surge animations that came out from that particular storm were fantastic. And you can use sea level rise within that framework to say, look, you know, this is what an 8-foot storm surge looks like. This is what it looks like, you know, because you have this additional inland flooding from higher sea levels, right? I mean, it definitely makes it very clear, and like, you know, because it's right, one of your main jobs, right, both the Weather Service and from broadcast, is right, protecting life and property. And so from that perspective, you can say this is the additional risk that we're putting on ourselves from this, without necessarily going into a full attribution and like fingerprinting type study that you might do as a scientist, which really takes a couple years of careful work.
Curious to hear from Sean on this one as well.
Sure, you guys can still hear me okay?
Yes.
Yeah.
All right. There are a lot of analogies that can be used in this situation, you know, and I'm in agreement with everybody here. You can't say X was caused by climate change. Again, we don't want to go into that binary argument. We could say that this is something that fits under the umbrella of climate change. You could say this is something that's more likely to happen more frequently with climate change. You know, we know that for every 1 degree of warming, there's an extra 4% water vapor in the atmosphere, at least the possibility, which you guys know quasi clapper on. You know, warmer water is going to provide more fuel for a hurricane. Clearly, there are other dynamics at play. We all know that. But all else being for such a situation, you have warmer water, the hurricane is going to be stronger. The other one, my favorite analogy, I actually saw several years ago from NCAR. Those of you who remember the steroid era in baseball, you couldn't say that any one person hit a home run because he was on steroids. But you could certainly say the number of home runs that were hit in that era was enhanced by the fact that there were so many more players on steroids. So if you want to say that the atmosphere is supercharged, it is on steroids, whatever kind of analogy you like, I think that's a good way to kind of prove it out. But you know, something that might have only happened once every 50 years now happens once every 10 or 20 years. You know, keep it kind of edgy because you can't leave it so exact. But you know, we've all heard about the once every 1,000 year storm. You know that's not exactly the best messaging. That's something that you say could statistically happen. It happens once every 50 years, and happens once every 10 years. So these are the kinds of ways you kind of fold it in to the messaging. Yeah, we can't say this climate change causes, but because the atmosphere is warmer, we see more energy, and these kinds of things are a little more common than they used to be.
Any other questions? Good, Jerry.
Dan, you mentioned as a possible solution, geoengineering. I guarantee if we mention that, you're going to hear from the chemtrail.
Yeah.
But I mean, you know, from a group up here, I mean, how likely do you see that as a potential solution somewhere down the road?
So just really quickly, it's already happening. It's not happening on a large scale. That's why. So, and when I say I see it as inevitable, I'm not saying it should happen. I'm saying it's just too easy to do, and someone's going to do it.
Well, the National Academy of Sciences has a board on weather and climate, and I'm on that now. And we're meeting in 2 or 3 weeks, and we're going to have to tackle this issue. We're going to have our first discussion about who's going to be on the committee to help write this report for the National Academy. And I want to stay away from this thing, I must tell you, because I think it's lunacy. I'll say that.
Yeah, but people thought adaptation was lunacy 20 years ago.
You know what people thought when the numerical weather prediction was first bandied about in 1946, right after the war? That it was going to primarily deliver an opportunity to explode nuclear devices that would reroute weather systems and change the atmosphere. Secondarily, it might give us an insight into the weather 2 days from now. That's a fact. That's a historic fact. So I'm concerned that something similar is maybe afoot, at least with some of the groups who are interested in this. They talk about putting aerosols in the stratosphere, and they model it somehow. And then I'm thinking to myself, wait a minute, how do you know how that cloud is not going, how is it going to be deformed today versus tomorrow by winds in the stratosphere? How do you know where it's going to end up? Who gets control of the thermostat? Like you said, Dan, there's an enormous amount of legal and moral and societal infrastructure that needs to precede any substantial experiments of scale. And I don't think we're there yet.
But if there's one thing we've learned about complexity, it's that whatever we do, we will be surprised. And so no matter what has to happen ahead of time, we will end up in a Wild West.
Yeah, well, I know to me, that's not a comforting thought. That's horribly frightening.
Yeah, I don't think it's a great one to throw at your viewers at this point.
Yeah, no, I think it's great.
I think it's worth it if you have local stories, right? I mean, to some extent, I like to talk about geoengineering in my undergrad climate classes, not just because people are out there thinking about it, but it's useful to think about the far extremes of like what you would possibly do if you really wanted to just deal with this one problem in absence of anything else about like food security or global conflict or water. And so it's nice to just kind of push people's minds. And certainly there's a lot of private industry that's really excited about renewable energy, about geoengineering. There's a lot of money out there, right? And so there's local stories, right? There's companies out there. I think there's companies even in Madison, right, doing algal biofuels and things like that. That's a form of geoengineering, actually, right? And so there are things that are worth talking about that maybe aren't a crazy, let's blow up 500 nuclear bombs in the stratosphere and make it 2% less sunnier. That seems kind of crazy, but there's things out there.
Yeah.
And that's where things like, you can point to, do you call green infrastructure geoengineering? Right? Because those are the sort of things you can point to and say, here's your actions people can take and are taking already, trying to be more resilient or carbon sequestration or anything like that. So that's all in geoengineering, and we tend to there's the scary side of it, and then there's the fact that I don't see any route forward where.
Well, I agree with you. I agree with both of you 100%. I just think that the appellation geoengineering already has a dark, sinister connotation, and so another term for the ones that are proximate, tenable, and probably useful ought to be adopted right now before it gets overclouded. That's all I'm saying.
Words in communication. So.
Yeah, that's right. That's right.
That's interesting.
I have a question.
I think Gary should stop.
Yeah, that's some good new terms for that. Softening the impacts. Someone mentioned freezing rain. What topics are hot item topics for your viewers and for your constituents? What are hot button topics?
For snow, there's always a big one.
Yeah.
Never fails. It can be trace, and we have massive traffic jams. It seems. So they're always very big, and what we have a chance, I guess, later in the week. So that's a big one. I don't know if anybody else wants to throw some ideas.
I'd say, good. I was just gonna say cold outbreaks and climate change events. Get some pretty sharp feedback.
Whether this flooding will create a 100-inch snow winter coming up. That's a pretty big.
Oh, yeah.
Really?
Yeah. Yeah, the general public is very interested in weather and climate and very intelligent. And it seems almost, like people don't generally believe that. I do. I think they're very interested and very intelligent, but they search for serial correlation when there may not be any, and they get disappointed when it's not there, and that's a message that has to be delivered with tenderness.
Has there been any
people saying that once they're impacted by something, they didn't believe, because I remember we did a story a while back, and some lady, more or less, she said, we had this 10 years ago, they said it wouldn't happen for another 100 years, here we are 5 years later, and it's happening again, I believe, like, do you see that the more of these events we have, the more people that are impacted, the more that sways them versus stuff, the actual facts?
I don't know. Is that directed to us? I don't know. I don't have enough. Yeah, I don't know. That's a good question.
But I remember like that, her interview really stuck with me, because like, she didn't believe, but then she's like, yeah, we had one 5 years, or we had a flood, and they said it was a 100-year flood, I'll never see one, and then here we are 5 years later, and I'm losing my house again.
Yeah, it's terrible. I suspect it has the right impact. It makes a person say, you know, if I was on the fence, I'm not so much on the fence anymore. I'm concerned, and I'll listen to the experts now if I wasn't
so as we
before.
have more of these unfortunate events, maybe more people.
Yeah, I think that it's human nature partly, right? We tend to be reaction driven to tragedies, whether that's my house falling apart, right? I'll just bandage it over, it'll keep going, right? And the roof falls in, or anything else. Even think of the stratospheric ozone treaty, and right, it was really, to some extent, there was a an analytical perspective to that. There was an alternative. There was a company willing to do it. But there was also kind of that visceral, like, whoa, suddenly we saw this large ozone hole on the satellite. It was on the cover of every magazine in 1986 or 87. And that got the public behind a treaty that was on its way to being signed, but really got a lot of buy-in as a result, I think. So I do think there are things like that. The problem with climate change, of course, is there's a lot of lags in the system, right? And waiting for... But I think you're right. I mean, the flooding in Madison, I've had more discussions about climate change locally, but that one event, just about any other, even the 100-inch snow year. And certainly the hurricanes, I grew up in Jersey, and certainly people there are talking a lot. That's a question.
Yeah. Well, I have two things now, actually. In response to yours, so I'm from northern Wisconsin, where there's been these, like, 1 in 1,000, 1 in 100-year flood events, and for a while they were captioned as such. We were like, oh, these were 1 in 1,000 years, especially like Houghton, Michigan. Gosh, just these intense floods this year. And there was feedback to that language. They're like, well, they're obviously not 1 in 1,000-year floods, and so there's this shift in language in the local forecasting where they're calling them mega rain events now. And I think that's an important shift in language, that we're not comparing this to historical data anymore, because we can't. That's not something that we can do. We're saying, no, this is our new reality. These are mega rain events. These are catastrophes that are becoming more and more common. And we can't say that they're not going to happen for another 100 years, because that's simply not viable. So I think the language shift in the scientific community, and that language that bleeds over, is a really important part. And then the other thing in response to your question that always gets a lot of people around me is it going to be a white Christmas? Are we going to have snow for Thanksgiving? The holidays are always a
holidays. Yeah. I think Sean mentioned that too, that those are packages that they focus on.
Yeah.
Interesting.
I had kind of a question for other broadcast nets. How often do you get, when you have a rain event, when, say, temperatures in the 50s and 60s, dew points are way up there as well, and you get the question, how much snow would happen? How much snow you would have gotten in that event? Then you have to get a wet blanket and say, well, you're comparing apples and oranges. How do you get those questions all the time?
Oh,
Do you actually do the computation, or do you just say, hey, just...
It's fun to do the computation, isn't it? I mean, but then you say, but it's not.
It's not much.
I did a segment on it, thanks to some math from Gary, essentially, where I broke it down and said, okay, well, if the atmosphere is colder, this is how much moisture it can hold at that temperature. So here's the math on that, and a lot of people were shocked that the August flooding would only be 30 inches of snow and not 100 inches.
Right.
They were so disappointed by that.
I, on the other side of it, said it's like comparing rain to unicorns. Inches of unicorns versus inches of rain. It doesn't matter.
And I have a question too for the communicators here in the audience. So Bob, you mentioned you're an AMS station scientist committee. That term station scientist seems to have really taken off in, I don't know since when, but I'm kind of curious how broadcasters view that role. And do you feel comfortable in that role? And like, are you being asked to report more on other science stories? And how do you tap into expertise in that? I'm just curious how that term has really taken off, or maybe it's not. Maybe it's just a buzzword.
It's actually been around for a while in the broadcast community. They developed the Station Scientist Committee. Paul Gross been back 10 years or more before. And so it was designed more as a resource for people whose stations wanted them to become more of the science expert as well. So on those slow days, they could report on something astronomical in nature that wasn't necessarily weather, and give the background for that. But with people like Bob, a lot of the things that have come on with climate change, I mean, that's becoming more and more of the big issue from the station scientist perspective. And so that's a resource for a lot of people, I think.
So the Weather Channel did that model for the last 8 years or so. The Weather Channel had in the afternoon would actually show them science on a big screen with meteorologists. Very similar.
Rather than showing the local forecast.
Exactly, over and over, or talking about coffee as well, which is that kind of video.
Well, this really goes to Bob's point that was echoed on a number of the slides with different second sentences that, I think the general public's most frequent contact with an actual scientist is through broadcast meteorology. And so that's a wonderful platform from which to launch these kinds of initiatives. And whatever degree of subtlety seems appropriate, it's really a special place. I completely agree with you about that.
And it helps when you venture out in the public to talk too. You bring that same credibility with you and that name attraction. You'll get more people at your events being you compared to bringing in someone that's not known. So, parlay that to as best you can, not only on the air, but in speaking to the public, face to face.
I'm kind of curious about what people thought about this event and whether it's worth doing again or in something else, or like, did people learn something here?
Definitely.
Okay. Yeah, we'll put on email. We'll definitely look for feedback, and we are going to look forward to doing it again and in new and improved version. So,
are any of your presentations going to be available online?
The live stream does have it recorded. We lost, I think, one of the talks because of technical difficulties. But we do have all the slides, so we can kind of find a way to share it. Yeah,
those slides are.
Yeah, we'll try to make those slides available as a group that matches up with this presentation. We'll see what we can do there for people. Because I know there's a lot on the live stream too that probably didn't see as quite as clear as we could hear. So I'll get those to them.
Yeah, Gary, if there's anything you want, let me know.
Yeah.
Okay, thanks, Sean.
Okay.
You've been very helpful.
Yeah, well, I went through the kind of central on the website there with those resources. It looks outstanding. So thanks.
Yeah, that was great.
Yeah.
Okay.
Well, I guess I'd like to say one other thing as well, and that is that that this idea of this being a conversation I think is really critical. One of my favorite things to do is to sit down and derive equations, right? Which doesn't connect with anyone, and there's no way for me to learn what's important to people. And so hearing from you about what people care about and getting that information from this community is really essential. And so I really encourage, get in touch with us, look up our emails, send us emails. Yeah. If there's opportunities for us to go out and give talks or for us to go out and sit down and have coffee with people, it's the sort of thing where we learn a lot from that, and it's really important. So I really appreciate everyone being here and getting your perspective.
Yeah. Okay, well, one more question? Yeah,
I
go ahead.
just wanted to say one thing. First of all, thanks to everybody for being here and having this. I really enjoyed this. I'm not a broadcaster here in the building. And sometimes, some of the stuff that happens here in the building, we don't hear about because it's just, we're all busy in our little world, learning about the atmosphere in some way or another. But I will say, probably a little too premature to officially announce this, but Neil Jacobs was supposed to be here in September. He had to reschedule. That has been rescheduled for Monday, November 26th at 2:30 p.m. over at the Union Varsity Hall. It's not technically been announced yet, but I know there's many people that are interested in that visit to talk about the implementation of the Weather Act.
He's assistant secretary.
He's assistant secretary for, of Commerce for, environments and predictions, something like that. So that's, going to be an interesting and engaging event, and that's open to the public and of course everybody here at the university.
Very good.
Okay.
Well, thank you very much,
Thanks,
Sean.
everyone.
Appreciate it.
Sean.
Thanks,
Yeah.
Sean.
You bet. Thanks to everybody for coming.
Thank
you.
Yeah.
Great. Yes, you guys, that was great. It's great to see you. And thanks so much for coming. Get this one. Some sort of follow-up support.
Great, okay, I look forward to it. I think this would be a great thing to continue to do. I really like the interaction.
Yep, I do too. Great. Thanks, and Cor, couldn't have done it without you. That was great.
Yeah, the technology all together.
I learned a lot too.
Yeah, I did. That's right. All right.
All right,
That's
very
good.
good.
Very cool.
Great job.
Thanks for getting this organized.
Yeah.